Good evening, good day, doctor. This is Sebastian Zertucci with Group 3, and this is what we got here. So right here is just a brief overview of our problem. Let me go to this one. So we have to determine the vertical deflection at point A with our F being 10.5 kips. Our moment is 3/4 of the yielding, just 2120, and then our plastic moment is 3180 kips per inch. And then we had to just compute the deflection at A with conditions for BC spaced into 3 segments and with 5 segments, all evenly split. So again, here's our yielding moment, plastic moment, EI or F, and the problem just restated. So I first started by just running it through a moment diagram at its full load at 10.5 kips, and we can see that basically from right here we can see that at 50.5 inches from the left, so we're talking right here 75, about 125.5, right here's where we hit our yielding moment, and then all the way to the end we're just before our actual plastic moment. So we know that the first segment, it still hasn't reached the yielding moment. Right here's just a quick overview of the equations that I used to get all the data. So our delta MI right here, I started by using the increment of load. So at first I used a 0.75 load times the distance from our segment to our point that we want to find the deflection about, which is A. So we have right here the case stated for 3 segments. So if this is 75, each one split into 50, and then the halfway point of each segment would be 100. So 75 plus half 50, 25, and then another 50 would be the 150 right here. Another 50 would leave us over here at 200. So that's where our distance is, our increment, and this gives us our delta MI. From here, this is where things got a little dicey for me, and I went back and forth with other group members. I know with Charlie and with Carolina and Savannah, but we know that our F force plus the distance plus the My is going to give us our Mi over here, and so our My is 2120, and I was really confused because at first I ended up doing Di, which would be 100 in the first case, times our force, and I didn't know if it was the full force of the 10.5 kips when we're just talking about that specific increment, or if it was delta F, the actual force increment. So at first I did it with the 10.5, and the numbers were just through the roof, like supposedly right away within like a second or third increment I was already past the plastic moment or the MP, and when I tried to calculate for my plastic EI, it was already, the formula would work out where the ratio from MP to the My should be 1.5. It was already passing that, so it's basically saying that it failed right away. And it just didn't make any sense, and I ran with it. I did it twice, which I'll show here in a little bit. I did it both ways, but then after talking to other groups who encountered, I think, similar issues, they believed that it must have been a typo here, and it should have been delta F, where I should have multiplied it by 0.75 instead of the full load, so the load increment. So I have both. And I'll show both. I would like some feedback on which direction to go. Right here is how we calculated our EI and our M1. So this is just an example. Again, this is the MEP that I got calculated from the last one, and this is our yielding. And what I was saying earlier is when I use 10.5 as my load increment, this number was already just blowing this one out the water. So when I would divide it, it would give me a negative number, so all of this would read negative, pretty much saying that it passed the plastic moment, because I knew right here because it was past our original, where are we at? It was past our original MP of 3180, so I knew that it had already theoretically failed, so it's why all this became just a jumble. and then my EI was already not calculated. Um, so the data that I'm showing here is using the incremental force. And then that happened to give me numbers that I could work with. So again, it's just a plug and chug through the Excel. And then the rest, I just rearranged the formulas to get our area, and then we multiplied the area times the distance to get our deflection. So that part seemed pretty straightforward as long as I got this part in line. And this part, of course, relies heavily on understanding this formula. So I did it both ways, but yeah, this is what I was able to ultimately get. I got the delta A right here with all my increments, and then my relative error. Just hope the numbers are okay. Let me go back and sorry, cut off earlier, doctor. But so right here is what I mentioned earlier. For some reason, this application that I'm using won't let me screen record while on Windows, so I had to just take screenshots of it. But I could send both files to you if you would like. So as we can see right here, I'm getting this. It's basically telling me that it's not working, and the reason I know why, it's because right here my moment calculated, it's already past my plastic moment, which is 3180 if I'm not mistaken, but it surpassed it. So of course it makes sense that right here these numbers aren't going to be calculated, because theoretically it went past the plastic moment, so it's no good. And when we put it into our equation for the EI, or I think it's the M1 formula, where we're taking the radical of it, it would be a negative radical. So that's what's happening here. The formula is trying to get a calculation for a negative radical. So this is why. And the reason why it's also not working, it's because it should have already failed. And I was getting this right away, so it just did not make any sense. I just hope I didn't misunderstand the process, but it didn't make any sense why this kept happening. So I spoke to other teams, and again, this was the result that they led me down, was to use the F instead of the full load, which in my case, for example, let's say at 0.75 increments, mine was like 10.5. So instead of using 10.5 and then 9.75 and then 9 as my formula to plug into the formula, they said use the increment, which is the 0.75. And of course that changed the number drastically. And then I got values that, again, like I got values, in other words, where half of these were just telling me that it's no good. So I hope this was the right way to go about it. Excel wise, it's all already been calculated, so any corrections would just take seconds to the formulas. And I did it manually as well, just the first step, and then it gave me the right answer. And I also went through lecture 4. I know the last like 15-20 minutes of lecture 4 is where you do a problem very in depth that's similar to the one that I was given. So I tried to just replicate it and follow your steps on paper, and then I actually plugged in your numbers to mine just to make sure I'm following the process correctly. And then it did work at first, but when I put in my other numbers, I got this mess, and I was just baffled because it just I don't know where it must have went wrong. And then once I corrected the load increment, instead of plugging in for F, I was told to put in delta F once again. Then it started to make a little bit more sense. And then again, our deflections didn't vary too much in the end by changing it, even though right here, theoretically, this is saying that the beam had already failed. The final increment was still 3.66. We got 3.66. But I would definitely just like some input or some feedback, or even an opportunity to correct it and learn from my mistakes. So thank you for your time, doctor, and hope to hear back from you. Alright, should be recording right now. Let me just go to your slide. Just 11 really. Let me go to slideshow. You're good. Alright. Cool, bro. I'll add it on.